Robots are becoming more and more important in our society. They are already part of our homes and our cities. Robots' physical autonomy is already well understood. They can observe, understand, and act on physical environments autonomously. However, very little research has been done on other kinds of autonomy. How can robots act on a social or economic environment? It is clear that robots are going to have great economic impact. Still, they can break or malfunction, and someone has to repair them. How can robots provide their own maintenance? If they pay for their repair service, they become peers, not just tools. We now ask ourselves, can robots become entrepreneurs? If yes, what does it need to become one? In an open market society, it is important that robots offer goods or services. To increase their autonomy, robots need to also get rewarded for their labor and be able to invest the benefits in their own sustainability. These ideas have been discussed before, but there have been extremely limited practical advances on robots' economic autonomy, and no prototype of an economically autonomous robot has been built until now. For instance, current robots are not able to accept payments from potential clients and/or pay service providers for their maintenance. Novel technologies, such as blockchain-based smart contracts, are offering new solutions to these problems. A smart contract is computer code embedded in the blockchain that directly controls the transfer of digital assets between parties. A robot using this technology operates in the physical space, but part of its interaction logic is described in a smart contract. Thus, the robot can perform its functions in both its economic and its physical environment. Let's take a look at the real proof of concept of an economically autonomous robot. Meet Gakachu, a robot arm that is self-employed in the making of customized physical goods, which it sells online in auctions. Gakachu uses its income to purchase supplies or assistance, or even to repay loans from investors. Gakachu starts with receiving a loan from an investor to cover initial costs. Then it selects a keyword trending online. It translates the word into Japanese and paints it on a canvas. Once the painting is complete, Gakachu puts it up for auction. After the sale, the physical painting is sent to the winning bidder's address, and the digital ownership certificate is delivered as a non-fungible token. Finally, the payment is transferred directly to Gakachu's blockchain-based wallet. Now, Gakachu can use its generated income to purchase human assistance or supplies from a web shop, or to repay an initial investor. During a 6-month period of self-employment, Gakachu created and sold 4 paintings. First, it used a loan from an initial investor to cover the startup costs. Then, Gakachu held 4 successful auctions and received payments to its own wallet. It used its funds to repay the investor loan and purchase supplies. At the end, Gakachu had earned more than 2 ETH and had interacted with humans economically in 3 different ways: as an investment vehicle, as a self-employed agent, and as a customer. This research creates new paths in robotics, economic theory, and law, and opens the door to future discoveries in fields like machine-to-machine interaction, online marketplaces for robot services, and human-robot organizations.